Exponential functions solve for the power. What are they? Exponential functions are functions such that y is equal to a to the x, where a is a constant greater than 0. Why? Helps to make financial decisions, including your retirement account. Interesting fact, fireflies are not flies, they are beetles. Now, let's take a look at the examples we're going to discuss in today's video. Let's take a closer look at example 1. Let's read the steps. Step 1. Are the bases squares, cubes, and so on? Step 2. If yes, use exponent rules. Step 3. If no, are the bases the same? Step 4. Combine and solve. Now, let's read the question. Solve the equation 5 raised to the power of 2x is equal to 5 raised to the power of 5x plus 3. Let's write down the given so we can show our work. First, we need to ask ourselves, does the base on the left equal the base on the right? In this case, both are 5. This is good news. What do we think is the next step? That's right, we can set the powers equal to each other. So now we have 2x is equal to 5x plus 3. Let's subtract 3 on both sides. So we have 2x minus 3 is equal to 5x. Let's subtract 2x on both sides. So we have negative 3 is equal to 5x minus 2x. Let's subtract 5x and 2x, and the result is 3x. So we have negative 3 is equal to 3x. Finally, let's divide both sides by 3. So now we have x is equal to negative 1. And that is example 1. Before we move on to example 2, let's verify, because everyone makes mistakes. Let's substitute negative 1 for x into our given. So now we have 5 raised to the power of 2 times negative 1 is equal to 5 raised to the power of 5 times negative 1 plus 3. Let's multiply the numbers. Now let's add negative 5 and 3. So now we have 5 to the negative 2 is equal to 5 to the negative 2. Both sides are the same. Sweet. Let's move on to example 2. Now let's read the question. Solve the equation 3 raised to the power of x squared is equal to 3 raised to the power of 7x minus 6. Let's write down the given so we can show our work. First, we need to ask ourselves, does the base on the left equal the base on the right? In this case, both are 3. This is good news. What do we think is the next step? That's right, we set the powers equal to each other. So now we have x squared is equal to 7x minus 6. Let's move 7x minus 6 to the other side, so we can have 0 on the right side. So we have x squared minus 7x plus 6 is equal to 0. Let's factor. What do you think the two factors are? That's right, x minus 1 and x minus 6. Let's set each factor equal to 0. First, let's solve for x minus 1 is equal to 0. Now, let's add 1 to both sides. So we have x is equal to 1. Second, let's solve for x minus 6 is equal to 0. Now, let's add 6 to both sides. So we have x is equal to 6. And that is example 2. Before we move on to example 3, let's verify, because everyone makes mistakes. We have two numbers to substitute, 1 and 6. First, let's substitute 1 for x into the given. So now we have 3 raised to the power of 1 squared is equal to 3 raised to the power of 7 times 1 minus 6. Let's multiply the numbers. Now let's subtract 7 and 6. So now we have 3 to the 1 is equal to 3 to the 1. Both sides are the same. Sweet. Second, let's substitute 6 for x into the given. So now we have 3 raised to the power of 6 squared is equal to 3 raised to the power of 7 times 6 minus 6. Let's multiply the numbers. Now let's subtract 42 and 6. So now we have 3 to the 36 is equal to 3 to the 36. Both sides are the same. Sweet. Let's move on to example 3. Now let's read the question. Solve the equation 9 raised to the power of 3x times 1/3 raised to the power of x plus 4 is equal to 27 times 3 to the x raised to the power of negative 4. Let's write down the given so we can show our work. First, we need to ask ourselves, do the bases on the left equal the bases on the right? In this case, it appears that they don't, but each one of the different bases is a square, a cube, and so on. What do we think is the next step? That's right, we need to rewrite each base as a 3 raised to a power of something. So 9 becomes 3 to the 2, 1/3 becomes 3 to the negative 1, 27 becomes 3 to the 3, and 3 to the x is still 3 to the x. So now we have 3 to the 2 raised to the power of 3x times 3 to the negative 1 raised to the power of 5x plus 7 is equal to 3 to the 3 times 3 to the x raised to the power of negative 4. What do you think we can do with the 3 powers that have powers? That's right, we need to multiply the powers by their powers. Now let's multiply the powers in the powers. Next, we can combine the powers on each side so we only have one base on each side. Let's subtract 6x and 5x, so we have 3 raised to the power of x minus 7 is equal to 3 raised to the power of 3 minus 4x. Now we have something we've seen before. What do we think is the next step? That's right, we can set the powers equal to each other. So now we have x minus 7 is equal to 3 minus 4x. Let's add 7 to each side. Now let's add 3 and 7 and add 4x to both sides. So we have x plus 4x is equal to 10. Let's add x and 4x. So we have 5x is equal to 10. Let's divide both sides by 5. So now we have x is equal to 2. And that is example 3. Before we move on to your turn, let's verify, because everyone makes mistakes. Let's substitute 2 for x into our given. So now we have 3 to the 2 raised to the power of 3 times 2 times 3 to the negative 1 raised to the power of 5 times 2 plus 7 is equal to 3 to the 3 times 3 to the 2 raised to the power of negative 4. Let's simplify the powers outside the parentheses. Let's multiply the powers by their powers. Let's combine the powers. Let's subtract the powers. So now we have 3 to the negative 5 is equal to 3 to the negative 5. Both sides are the same? Sweet. Now it is your turn, so go ahead and pause the video here so you can take your time to answer this question, and I'll show you the result in 3, 2, and 1. Did you get it correct? Super. If not, there's always tomorrow.